Friday, when I was gone, you did the notes on the collision theory and nature of the reactants and things like that. Today we're going to talk about rate law. This is, let me be clear, a very minuscule, small part of rate law. Okay, rate law is normally determined experimentally. If you go on to take AP Chem, it's a lot more involved. So we're doing kinetics light, basically, or pseudo-kinetics. Okay. So the rate law is a mathematical expression that relates the concentration of the reactants to the reaction rate. It is found experimentally. And it is based upon the slowest step in a reaction mechanism. What is a reaction mechanism? Good question. I'm glad you asked. Thank you, Natan. A reaction mechanism is basically this. So when we have seen our balanced equations to this point, we've seen the overall balanced equation. However, it doesn't happen usually in one single step. There is a series of steps that often happen, and things are formed and break down and then used up, and then you get the overall reaction. Okay, so here is an example. Okay, so this is our reaction we're looking for. Okay, so that's the overall reaction. Excuse me. And these are the steps it takes to get there. Okay, and so remember when we did Hess's law and we rearranged equations and we crossed out things that appeared on opposite sides? Similar concept. We're going to cross out things that appear on both sides and get our overall reaction and then add them up. So we're going to put our little thing down here, and I see that the first step is A creating B. And then I see B creates C, and then I see that C creates D. So I'm going to cross out the things that appear on opposite sides of the equation, and that is B and then C. Okay? And then my overall equation is A to D. B and C are something that we call intermediates. They are formed and then used up in one of the subsequent reactions. The way that you will recognize if something is an intermediate is it's created and then it's used up in another step. Okay, and it doesn't appear in the overall equation. Okay. We could add something called a catalyst, which we talked about on Friday. Catalysts do what with the reaction? Speed it up. Okay. So let's say this reaction actually had a catalyst. What letter do we want to use for our catalyst? Q. Okay, we'll go with Q. So let's say that this equation, let's change it, and we said this was B plus Q yields C, and then this equation became C yields D plus Q. I would still cancel out Q, right? But Q would be a catalyst. How do I tell the difference between an intermediate and a catalyst?
Catalyst isn't used, or catalyst doesn't change.
Huh?
Doesn't get used up or changed.
It doesn't, but here, how would I tell which is the intermediate, which is the catalyst?
It's a different catalyst appears on the side.
The catalyst appeared as a reactant and then as a product, showing that it was still there. Okay? Whereas the other one was consumed. It was created and then consumed. Okay? So that's very good. So that's how you tell the difference between a catalyst and a intermediate. Okay? And just to reiterate what y'all did on Friday, catalysts do not participate in the reaction. They actually provide an alternate pathway with lower energy. Okay? So they're not used up. So those are the reaction mechanisms. Okay? Now, we're going to come back to this, so we're going to come back to this in a second. Okay? So here's another example of iodine and hydrogen making hydrogen iodide. Okay? This should also be crossed out. That one got left out. So what happens there is the first step is I2 breaking down into two individual iodines. Okay? I need to do a different color, don't I? Y'all can't see that. I know, it's not. Let's do just, okay. So the first step is I2 creating two I's, and then the next step is an I reacting with a hydrogen, forming an H2I, and then an H2I reacting with another iodine to finally form the HI. So these are going to cancel out because there's two of them. So that cancels that. And then this and this cancel. Silver, I think it's just white.
It's just white.
Yeah, it's white. It kind of looks silver though. We'll go with silver. It's silver. I'm fancy. Okay? So in this case, the I, let's go back to a different color now. The I and the H2I are your intermediates. Okay? There is no catalyst present. Okay? And so that would be your intermediates. Okay? So there can be more than one reaction pathway that can be taken for a chemical reaction. Species that appear, we said, of course, are not involved or they're consumed. We call those the intermediates. Okay? When we're writing the rate law, and we're only going to do this for single-step reactions or mechanisms that I show you. In AP Chem, they're given a series of data, and they have to determine what the rate is based on if I increase the concentration, what happens to the rate. If I double the concentration, what happens to the rate? We don't do that in here. Okay, we're only going to do for single steps. But the way we write it is, first of all, only the reactants appear in the rate law, never a product. Okay. And then when we look at that, we're going to take, these are the coefficients, and we take them and raise the concentration to its coefficient. Okay? So if I said 2H2 plus O2 yields 2H2O, my rate would be K, which is my rate constant, concentration of hydrogen raised to the second power times the concentration of O2. So that's how I would write that. And remember a while ago I said when we're looking at mechanisms, it's the slow step that determines your rate law. So once you get to the slow step, you don't write anything else down for your rate law. Yes?
What is K? Is it a specific number?
It's a rate constant. It's different for every reaction. You can calculate it if you know the concentrations and the rate. Yeah. So this would have its own rate constant. Another reaction has its own rate constant.
Can you give us that value?
No, normally I'm going to ask you to solve for it. So I'm going to give you the rate because I can measure rate, correct? Like I can start a reaction and measure out my concentrations and I can figure out the rate at which products appeared. So I can know that, so I can figure out my rate constant. Which we're going to do here in a second. Okay? Okay? So let's go back to that we had A going to B, oops, B going to C, and then C going to D. And we said our overall reaction was A going to D. Let's say I tell you that this is my slow step. I could actually figure out that this is my slow step if I hadn't told you that, because based on that, my rate is going to be equal to K concentration of A. So even if I hadn't told you that that was the slow step, you could figure that out because nothing past there appears in the rate law. So when you get to the slow step, you stop writing things down for your rate law. Until you get to the rate law, you just keep adding them up. Unless it's an intermediate. Intermediates or catalyst or products do not appear in your rate law. Okay? So let's do an example with the math. Okay, so when we have the rate law, we have the exponent for each reaction. We call it its order. And the sum of all the exponent is the overall order of the reaction. Okay? So if I was going to write this rate law for this particular, equation, here is my rate law right here for that reaction, NO2 times CO. I would say that this was first order with respect to NO2 and CO. They're both first order. And then I would say it's second order overall. So the overall reaction is considered to be second order. Now when you get to AP Chem, we can graph certain things and determine graphically whether it's a first order, second order, or third order, or zero order. Sometimes you can have a zero order, which is just rate is equal to K. So here we have this equation. A plus 2B, that's supposed to be a yield. And I think yours says A equals on your paper. So change that to a plus sign on your notes. Okay? So it wants us to find the rate constant when we have A and B both being equal to 0.2 molar, and it gives us a rate constant. So the first thing we need to do is actually write the rate law. So how would I write the rate law? Okay? And B squared. Okay? Because of this 2, I got to have B raised to the second power. So for this reaction, it's first order for A. What order is it for B? Second order. And what's the overall order? Third. 1 plus 2 is 3. Yeah. So you're adding up the exponents to get the overall order. So the overall order is third order. Okay? First order for A because there's only an exponent of 1. Second order for B, but third order overall. Does everybody understand that? Okay. So now I want to solve for K. So I'm going to rearrange and say rate is A B squared. So now I plug that in. The rate is 2.0 times 10 to the 4th molarity per second. And then 0.2 molar, 0.2 molar squared. So when I do all that math, put everything in, I get 2.5 times 10 to the negative 2. Now let's talk about units. Okay? The units on a rate law problem get tricky. And so much so that on the AP exam they often give 1 point for the answer and 1 point for the units if you see if you get the right units. So I'm going to do this. I'm going to leave that down there. But we're going to look at our units. So if I just look at my units, I have molarity over second over molarity cubed. Do you agree with that? Okay. If that top part is molarity over second, where is the second for reals?
On the bottom.
And what can I cancel out? I can cancel this out. So now I have 1 over squared second. Okay. However, I'm going to show you this because in AP they don't ever write it that way. And this threw first period for a loop. I confused them. What you will see, and you'll see this in sometimes papers and worksheets, you'll see it written as this unit. All that means is when I write it as a negative exponent, it just means it's supposed to be on the bottom, right? So my final answer, I personally would write like this. That's a 1. I don't know what, like that. Okay? So if you see it that way, don't let it confuse you. But I also give you a little tip. Whatever your overall order is, the unit on your the exponent on your molarity is going to be 1 less. So we had third overall order, so we're going to have M2 because the 1 molarity is going to cancel out with the other ones. Huh?
Add the exponents.
On right here, I add the exponents. So 1 plus 2 is 3. So it's third order overall. Yes, ma'am.
So if it's A raised to the second and B raised to the second, then what was the order of A?
If it was 2A plus 2B, so it'd be fourth order. You just add the exponents up.
And then, or the order of just A raised to 2.
Yeah. So for this one, what I would say, the way we have it written, that this rate law or this reaction is first order with respect to A, second order with respect to B, and third order overall. Okay? Any questions?